Paper begins its life in carefully managed forests, where trees are grown not randomly, but as a renewable industrial crop. Softwood trees provide long fibers for strength, while hardwoods offer smoothness and print quality.
Most paper trees are harvested after 7 to 15 years, far faster than natural forests regenerate. Modern forestry relies on data, soil science, and biodiversity management.
Growing trees absorb carbon, making responsibly sourced paper part of a renewable cycle.
Once trees reach maturity, precision harvesting begins. That is where nature meets machinery. Today's logging is a highly controlled industrial process designed for speed, safety, and efficiency. A single machine can cut, strip, and section a tree in under a minute.
Debarking reduces contamination and improves pulp quality.
Not all logs become the same paper. Sorting determines the final product. Paper mills consume thousands of tons of wood every day. Road, rail, and water transport connect forests to mills worldwide. Once inside the mill, wood begins its transformation into pulp. The journey from wood to fiber is about to begin. Before fibers can be released, wood is reduced into carefully sized chips.
Uniform chips ensure even chemical penetration and consistent pulp quality.
Mechanical pulping preserves most of the wood, producing high-yield pulp for newspapers. Chemical pulping dissolves lignin, freeing strong cellulose fibers. High temperature and pressure break lignin bonds without damaging fibers. A rapid pressure release completes the pulping process. Different pulps serve different paper purposes. Now the fibers must be cleaned and refined. After pulping, fibers must be thoroughly washed to remove chemicals and impurities.
Effective washing improves fiber bonding and final paper quality.
Screens ensure only properly separated fibers continue forward. Centrifugal cleaners use rotational force to protect paper machines from damage. Refining enhances strength by increasing fiber surface area. Even small changes in fiber consistency affect final paper performance.
At this stage, fibers are clean, uniform, and ready for brightness treatment.
The next step determines how white paper becomes. Modern mills use oxygen and peroxide to reduce harmful chemicals. Peroxide brightens fibers without damaging cellulose strength.
Brightness depends on perfect control of temperature and pH.
Each paper grade requires a specific brightness target.
Waste chemicals are treated before water is released back into nature. Now the fibers are bright, clean, and ready to become paper. This is where liquid pulp transforms into solid paper.
The paper machine is the heart of the mills. One continuous system running.
The head box controls flow, consistency, and fiber orientation. Pressing increases strength while reducing energy needed for drying. Steam-heated drums evaporate remaining moisture.
At over 100 kilometers per hour, control systems prevent sheet breaks.
From liquid pulp to solid paper inks, without ever stopping.
But paper's surface journey has just begun.
Raw paper is functional, but coating defines how it feels, prints, and performs. Clay, calcium carbonate, and binders determine brightness and ink absorption. Microns of difference decide print quality. Different papers require different surface treatments. Calendaring compresses fibers to achieve uniform finish. Each finish serves a specific industry. Modern systems detect imperfections instantly. Now, precision meets logistics. At this stage, paper is produced in reels weighing several tons. Millimeter-level precision ensures compatibility with printers and converters. Thousands of sheets are cut every minute without stopping production.
Robotics reduce damage, errors, and human fatigue.
Paper must be protected from moisture, dust, and impact.
Each roll is digitally tracked from factory to customer.
Efficient storage ensures rapid global distribution.
Before shipment, every batch is tested. Before paper leaves the mill, it undergoes rigorous testing to meet international standards.
Tear resistance ensures durability in printing and packaging applications. Proper moisture levels prevent curling, wrinkling, and ink issues.
Surface smoothness affects printing quality and tactile feel.
Every sheet must meet brightness targets to satisfy printing requirements. AI-assisted detection ensures errors are corrected instantly, reducing waste. Packaging grades are tested to withstand real-world shipping stresses.
After rigorous testing, paper is ready for the world.
Sustainable paper begins with efficient collection and sorting of post-consumer waste.
De-inking restores fibers to a neutral color while maintaining strength.
Recovered fibers are mixed with fresh pulp to maintain quality.
Modern mills minimize environmental impact through strict regulations and innovation.
Recycled fibers are carefully refined to ensure comparable durability to virgin paper.
The future of paper includes biodegradable, compostable,
and innovative functional papers.
Recycling reduces deforestation, conserves energy, and lowers carbon emissions.
From forest to recycled paper, the journey blends science, industry, and environmental responsibility.
The story of paper continues, evolving to meet the needs of a sustainable future.